Oh yeah, I noticed. It's okay. I know it happens. It's okay. Thank you. Okay. I hope I'm recording and then I can upload this. So I'm just gonna kind of hopefully go quick. All right. So follow along here. We're finding this side. Even though the question is to find this one, I need to get this side. You start with the triangle that has the two given sides. You find the third side. So it'll be 4 plus 9 equals c squared. That'll be 13 is equal to c squared. You take the square root of both sides. Okay, so we get c is equal to the square root of 13. See, that's the side that's missing, and actually that's going to happen to be the side that they have in common. This is the square root of 13. You guys see it? And then, see, yeah, there's another person that got kicked out. Okay, now, once you find this side, and you notice that's the side that they share in common, now you have what? Now you can work with this triangle, because now I got two sides. And you can find the third missing side. So you see what I mean? It's not too far from what you already know, but I want to just throw it out there. And then you guys are like, well, we never saw this. So yeah, start with the triangle that has the two sides, find the missing side, and then that side coupled with the other side from the other triangle, then you'll do what? Now you find x. Here you can use, right, we'll do this again. Now we can solve. This is the value of x that they want you to find. Right? And so we do this quickly. Remember, the c side always goes first, right? The hypotenuse side is the c side. So that's 9 squared is equal to, and then the other ones, I'll make this one a, and I'll make this one b. Okay, so that'll be x squared plus 13 equals 81. X squared equals, where's my calculator? Let's see, 81 take away 13. 68. 68. And then you're going to get, you square root both sides, you square root both sides, you get x is equal to the square root of 68. And then we check if we can simplify this. How do I check? Well, let me see. I'm going to try dividing 68 by 4, right? A perfect square number. The first one's 4. Oh, it is. Look, it works. 68 divided by 4 is 17. So that means that what? If 68 divided by 4 is 17, that means 17 times 4 is 68, right? So that means that 68 is 4 times 17. And then the 4 comes out, right? A 4 is a perfect square root. So your answer is 2 root 17. All right. Okay, the other one, number 2. And I believe I'm recording this so I can upload it, but if not, just follow along with the notes. Follow along and copy this down. Number 2, this doesn't even look like it. This isn't even a right triangle. How could this be a Pythagorean Theorem problem? Okay, this is actually a trapezoid. Okay. So, if you notice, this side is 10. Okay, that's the bottom side. And you notice this side is 10, which really they don't have to be the same. And then you notice this longer side is 15. Okay, so what you're going to do here on this part here, wherever you see kind of like the square or the rectangle, you're going to have to actually complete it and draw it out so you can see what's happening here. If you go across here like this, if you just kind of go just lightly, right, I'm going to complete this square, I'm going to complete this rectangle. I know that this is 10, that means that this one's what? If this one's 10, then this one's also what? 10. Alright, if this one's 10, this one's also 10. And sometimes this one will be different. This one doesn't have to be a 10. Sometimes it could be a rectangle. It could be 8 or 9 or whatever. But it just so happens that this is a square, right? Even if it's a rectangle, rectangle also has 90-degree angles. And that'll make that a 90-degree angle. while it happened to be 10, if this is 10, that means from here to here is 10. And if it tells you that the whole thing is 15, I got from here to here 10, but the whole thing's 15, that makes this one what? 5, right? 5. Because these two add up to your 15. And then that's how you get, so now you have the two sides of this right triangle over here. So now you have, this side is 5, this side is 10, and then they ask you to solve for x. Let me give you a different one, because this one gave you, this example gave you a perfect square. I mean a square like the shape of square. But if it was not, it would look like, just real quick, let's say I do it this way. What if I tell you that this isn't, just watch, this is 20, this is 12. Right? This is 20, this is 12. We're trying to work with the right triangle, which is obviously going to be over here. So what did I tell you to do? This part right here, make it, complete it. Sometimes it'll be a square, sometimes it'll be a rectangle. And these are going to be 90 degrees. But more importantly, this one's going to be 90 degrees. Remember, this whole distance is 20. Oh, I need to give you another number. I forgot, I'm supposed to give you another number. Let's say this is, whatever, this is 14, sorry. I missed the number. Okay. So remember, for this one here, don't worry about the triangle. This is a rectangle. If this one's 12, well then that means this one's 12. And if this one's 14, that means this one's what? 14. This helps me get this side for the right triangle. And then how do I get another side? Right here. If this whole thing is 20 and this is 14 from here to here, how much is this missing little piece? It's going to be 6, right? It's going to be 6. Yeah? And then there you go. That's the main thing I need, right? I need two sides. I need two sides of a right triangle to be able to find the third missing side. So now you would just kind of look at and focus on this right here, this triangle here, which is 12, 6, and then you find the missing side. They're gonna ask you for this one. Okay, let's move on. What about a couple of more word problems here? Ooh. This first one's pretty easy. Actually, they all are, believe it or not. They're all pretty easy. I just want to make sure that you see it here. Okay, hold on. Let me zoom out here. Okay, you start driving north for 8 miles. Let's just read it through the first time, right? You start driving north for 8 miles, turn right, and drive east for another 6 miles. Okay. At the end of driving, what is your straight line distance from your starting point? Okay, this one's easy, okay? And sometimes you gotta read these a couple of times so that you get it. Okay, I hope everybody knows their direction, right? Everybody knows north, south, east, and west, yes? Everybody knows north, south, east, and west. Okay. North is up, south is down, east is to the right, west is to the left. Okay, that should be common knowledge. All right, so let's just pick a point. You start right here. You just start right there. You start driving north for 8 miles. North is which way? Up. You drive up for what? 8 miles. And then it says turn what? turn right and drive east for what? And if you make a perfect, and if you go east, you know that's 90 degrees, right? And then you go east for what? 6 miles. And then you stop. Now you're here, right? I mean, that's it. They already drew like your 90-degree angle, and you got what? 2 sides. Guess what the question is? At the end of driving, right? I went this and I went like this. I went 8 north and 6 east and I stopped, right? At the end of driving this, right? I'm right here now. What is your straight line distance from your starting point? So they're pretty much asking you what? I mean, how simple is that? And there it is. That's Pythagorean Theorem. You got 2 sides, and they're asking you for the 3rd side. And you guys can solve that on your own. A different word problem. Is that good? That was pretty easy, huh? Okay. A different one says this. Before I tell you this, before I show you this one, let me explain something to you. You guys know when you buy a television, you know there's televisions that are different sizes, right? Here's your television. That's like the screen, right? When you have a, oh, by the way, it's like a rectangle, right? It's not like a square. I don't think you see televisions that are squares. You see them, they're rectangular. So that means you got a longer side and you got a shorter side, right? The length and the width or whatever. Or the width and the height. So if you have a 50-inch TV, I mean, now they make like 85, right? 85-inch, that's crazy. But anyways, if you have a 50-inch TV, which one's 50? This one, the length, or the width? Well, the answer is neither. This when you hear, oh, I have a 50-inch TV, oh, I have a 80-inch TV screen, whatever. That dimension is actually the diagonal. That's the measurement. When I don't know if you guys knew that. When they tell you have a 50-inch TV, it's 50 inches on the diagonal, not the height and not this. It's on the screen like this, a diagonal. Okay, now that you know that, I'm pretty sure maybe a couple of you probably knew that already. All right, easy problem. I mean, you could already see the right triangle, right? So let's just set this up. The second one says, a certain television, oh, it says 50. Huh. Let me draw my TV. I just made that number up. Maybe because I saw it there. A certain television, right, is advertised as a 50-inch TV. Oh, it even tells you right there. Oh my God, diagonal length. Oh, come on. And I mean, come on, you guys can already see the right triangle here, right? Let's just look at this one here. This is my right triangle. If the width of the TV is 14, how tall is the TV? Oh, so here's your width. This is your width, because how wide is it? And then how tall is, how high is it, right? So it says that the width is what? 14. Then the question is how tall is it, or how high is it? I'll put T. So 14 is the width, and then you could put T for tall or X or whatever. I mean, but long story short, they're already, I mean, you guys see the triangle there. 50 inches, 14, and they're asking you for that. Sometimes they'll give you the width. Sometimes they'll give you the height and ask you for the width, but I mean, I think it's an easy Pythagorean Theorem word problem, and you guys can handle it. Okay, last one. If you place a 26-foot ladder against a 10-foot building. Now, let me explain something to you. If you have a building, let's say the building is, or whatever class or whatever something, a house with a wall, it doesn't matter. Let's say this is 15 feet, right? Let's say this is 15 feet. I can't use a 10-foot ladder. I can't use a 10-foot ladder to get up here, right? A 10-foot ladder wouldn't reach, see? Wouldn't reach. It has to be more than what? It has to be more than the height. Even if it was 15, even if the ladder was 15, right? The ladder, ladders look like this, right? Even if the ladder was 15, you couldn't use it because you can't put a ladder like vertical like this. You'll fall over. It has to be longer. Okay. So this question says that your ladder here, here's my ladder, is 26 feet and the building is 10 feet. Okay, that's doable. So put your ground, put your building. This is 10, this distance is 10. I'll put a 10 right there. I know this is my right angle. And the ladder is 26. So I know the ladder has to be leaning like this. So the ladder is 26. See, this is your ladder right here. If you want to draw a ladder, go ahead and draw a ladder. Whatever. If you place a 26-foot ladder at the top, see, at the top of a 10-foot building, how many feet will the bottom of the ladder be from the bottom of the building? Well, obviously they're asking you for this. From here, from the bottom of the ladder to the bottom of the building, how? And then you can see right there your right triangle, right? You can see your right triangle right there. You're going to work this out like this. It's going to be 26, 10, and then find that. Okay,